Greetings to all. My name is Parnika Kansal and I'm here to present my topic Cognitive Healthcare System, which is a deep learning based spectrum prediction solution. The prevailing pandemic scenario and the constant explosion for wireless devices leads to a demand for a larger spectrum. That is why we have proposed a smart solution for healthcare based on the latest technologies. In this figure, we can see advanced technologies for smart healthcare system. These technologies can aid in enhancing the diagnosis and treatments by spectrum sensing and allocation for transmitting the medical data for remote therapies, medical imaging, and other identification of patterns in the diseases. These technologies are mainly the Internet of Things, deep learning predictors, blockchain method, Industry 4.0, cloud computing, and big data algorithms. In this particular figure, we can see many smart blocks which have been deployed for deep learning based cognitive healthcare system. The cognitive radio users in the first block are comprised of patients and the primary users and the secondary users. The next block is known as the IoT-enabled sensors that have a wearable technology that can be mobile or fixed in motion and act as the cognitive radio users. The next block is the short-range network, which acts as a local area network and comprises of low-distance communication components like Bluetooth and RFID. This block acquires the data from IoT-enabled sensors and passes it on to the smart hosting block. The smart hosting block has various types of intelligent equipments, smartphones, laptops, which can store and transmit data. The next block is the long range network or the wide area network, which sends information in real time to the cloud. The next block is the cloud supervisor block, which has a cognitive engine and a deep learning predictor server. Over here, the data is classified into high, medium, or low priority risk for the patient so that the emergency patient can be allocated the spectrum at a higher priority. The next block diagram is representing the flow chart of the proposed spectrum prediction and allocation algorithm. Over here, the gray model and the LST module work together for classifying the risk patients into high, medium, and low. Over here, the training dataset is comprised of the patient medical data, electronic health records, lab reports, and the patient's energy and the other data, which is a time series data because the gray model can be integrated with the LSTM for classifying this time series data. The next flow diagram is a spectrum prediction steps for the LSTM and gray model. In this, we are illustrating the steps for training the dataset, which is first pre-processed and the redundant null data is filtered out. After this, the parameters of the LSTM model are adjusted for the overall spectrum prediction outcome of the model. Then, the LSTM predictions are formulated and compared with the estimated values in the dataset, and the remnants produced in the predictions are evaluated. Finally, these remnants produced are revised by the gray model to compute the final spectrum predictions. These final spectrum predictions are used for transmitting the medical data for the remote healthcare and other applications by the deep learning. Thank you.